Hey guys, welcome to the second day of the online notes. Today we're doing section C.5, like that means anything. Just means we're doing chapter circles, and we're doing the fifth section of chapter circles. This shouldn't take too long. We're going to learn 3 more rules about the circles, and then off you go to the homework. So here we go. Let me set the camera up. Okay, so today, there we go. So today we are looking for segment lengths within a circle. And there are 3 types of segments that we look at going around the circle. And those would be the chords, which are segments that go from the edge to the edge of a circle. Tangent lines, which touch at one point on the circle, and secant lines, which cross the circle at 2 points. Right? We have already covered that 2 tangent lines to a circle. Right? 2 tangent lines to a circle, and this is important, from the same point outside the circle are the same length. And now we're going to look at 3 other situations. And these are not that hard. I don't think you'll have any problem. The first is 2 intersecting chords. So I have an example here. When 2 chords intersect, the product, that means you're multiplying, right? The product of their parts are equal to each other. I said that weird. The product of their parts are equal to each other. So my little circle over here, I have one chord that has, we're looking at where they cross, and in one chord the length is A on one side and B on the other side of where they cross, and on the other one it's C and D. And this rule simply says that if you multiply A times B, that will equal multiplying C times D. So you can find missing lengths that way, and I have an example for us to do. I think this one's really easy, but here we go. So if we are looking for the value of y, we could set up an equation, and we know that 8 times 3 equals 6 times y. So the multiplying the 2 lengths of one chord equals multiplying the 2 lengths of the other chord. That would mean 24, of course, equals 6y, and if we divide by 6, we would get y equals 4. And of course we could check our answer. 6 times 4 does equal 8 times 3. So there you go. The second example here is 2 secant lines from the same point outside the circle. So here I have 2 secant lines from my point. Now, a secant is broken up into 2 parts, right? There's a part that's outside the circle, which for this secant would be called part A. That is called, by the way, the external part, but I'll probably just refer to it as the outside part. And then we have the part that's inside the circle, and that is part B. Now, on the other secant, the outside part is C, and the inside part is D. And our rule for secants is that the outside part times the length of the whole secant will be equal for each secant. So if I multiply the outside part times the whole thing, that will equal the outside part times the whole thing. And here I have it down here in variables. So A, that's the outside part, and A plus B is the whole thing. And the other secant, C, is the outside part, and C plus B is the whole thing. And so I have an example here. And we can do the example. So for this one, 7 is the outside part, and I would be multiplying that times 11 plus 7, or that would be 7 times 18. That would be the top secant. And then the bottom secant, 6 is the outside part, and the whole thing would be x plus 6. Sorry about that. I did not help you out very well there. So 6 is the outside part, and then the whole thing would be x plus 6. So again, I have the outside part times the whole thing equals the outside part times the whole thing. And I can solve this. 7 times 18, that is 126. I would distribute the 6 and get 6x plus 36. I would subtract 36 from both sides and get 90 equals 6x. And I would divide both sides by 6 and get x equals 15. So in this case, this length here would be 15. And 6 times 21 should equal 7 times 18, which it does. All right, the one thing you want to look out for there is, well, I think we'll see it in the next one, so I'll just wait till now. The next one's the hardest example. All right, our last rule is when we have, let me get set up so you can see it. There we go. When we have a secant and a tangent. So you can see the secant is broken into 2 parts, but of course the tangent is just 1 part. And these are still from the same point outside the circle. And our rule here is similar to the last one. Outside part times the whole thing equals the tangent squared. Right? Outside part times whole thing equals the tangent squared. So you can see in letters here, I have A is the outside part, and A plus B is the whole thing. And that equals the tangent, which is C squared. So I made this one tough on purpose. You're going to want to work through this one with me probably. So here we go. We want to find the value of x, and we want to find the length of mn once we know x. So this time I have some variables here. I have the length from m to l is x minus 3. From m to n is x plus 3. And LK, which is this chord inside the circle, is 16. So let me see if I can follow my rule here. Alright, so first let's take the secant. I want the outside part times the whole thing. Well, the whole thing is x minus 3 plus 16. Or if I write that meter, that would be x plus 13. And so that is what the outside part times the whole thing looks like. And we have to remember how to multiply those together. On the other side of the problem, I have the tangent here, and I have to square it. So that would be the x plus 3 squared. So we need to remember how to square a binomial, or a polynomial that's got 2 terms. So let's do the left side first. The left side, I need to multiply x times each thing. X times x gives me x squared. And then x times 13 gives me 13x. Then I need to multiply negative 3 times each thing. Negative 3 times x gives me negative 3x, and negative 3 times 13 is negative 39. And let's go ahead and simplify that by adding our like terms together. And we will get x squared plus 10x minus 39. Now on the other side, we have to do x plus 3 squared. Now remember, that is not x squared plus 9. You need to take the x plus 3, and when you square it, you multiply it by itself. So, I need to multiply the x times the x, giving me x squared, the x times the 3, giving me 3x, then the 3 times the x, giving me another 3x, and the 3 times the 3, giving me 9. And when I clean that up, it would be x squared plus, I'd combine the 3 x's and get 6x plus 9. Now I am ready to solve this thing. And we are fortunate that the x squareds will cancel each other out. So let's get rid of those. And then I can solve this fairly easily for x. I would subtract the 6x from both sides and add the 39 to both sides. And I have 4x, and over here I have 48. And obviously then if I divide both sides by 4, I get x equals 12. So I now have the x value. Let's go back up here to our little drawing, and we can see that x equals 12, and here's the length of mn. The length of mn is x plus 3, so that would be 15, right? Okay. That is all. Good luck on the homework, and we'll see you tomorrow.